in spherical polar coordinate, the Cartesian coordinate are given x equal to r sin theta cos phi, y equal to r sin theta sin phi, z is equal to r cos theta, and we have to prove that the Jacobian x, y, z with respect to r theta phi, which is equal to r square sin theta. That means we have to prove that Jacobian in spherical polar coordinate is equal to r square sin theta. So the Jacobian, we have to find out the Jacobian of xyz with respect to r theta phi, and we know from the definition of Jacobian that is equal to partial derivative of xyz with respect to r theta phi. Jacobian is also written in determinant form like this, that is partial derivative of x with respect to r, partial derivative of x with respect to theta, partial derivative of x with respect to phi, then partial derivative of y with respect to r, partial derivative of y with respect to theta, and partial derivative of y with respect to phi, then partial derivative of z with respect to r, partial derivative of z with respect to theta, then partial derivative of z with respect to phi. And it is given that x is equal to, in the question it is given that x is equal to r sin theta cos phi. So partial derivative of x with respect to r will be equal to sin theta cos phi. So here the partial derivative of x with respect to r equal to sin theta cos phi. Similarly, x is given r sin theta cos phi. So partial derivative of x with respect to theta is r cos theta cos phi. So here r cos theta cos phi. Then partial derivative of x with respect to phi, partial derivative of x with respect to phi will be equal to minus r sin theta sin phi. So here minus r sin theta sin phi. Then partial derivative of y with respect to r, y value is given r sin theta cos phi. So partial derivative of y with respect to r is equal to sin theta sin phi. So this term will be equal to sin theta sin phi. Then partial derivative of y with respect to theta, partial derivative of y with respect to theta will be r cos theta sin phi. So this term will be equal to r cos theta sin phi. Similarly, partial derivative of y with respect to phi, here partial derivative of y with respect to phi will be equal to r sin theta cos phi. So this will be r sin theta cos phi. Then partial derivative of z with respect to r, if you it is given z is equal to r cos theta, so partial derivative of z with respect to r will be equal to cos theta. So this term will be equal to cos theta. Then partial derivative of z with respect to theta, partial derivative of z with respect to theta will be equal to r sin theta minus r sin theta. So this term will be equal to minus r sin theta. Then partial derivative of z with respect to phi, partial derivative of z with respect to phi will be equal to 0. So this term will be equal to 0. Now we will find out the determinant of the given Jacobian. So to find the determinant, first for this sin theta and cos phi, you leave this column and this row and this column and multiply r cos theta sin phi with 0, which is equal to 0 minus, again a minus, r sin theta into r sin theta cos phi, that is equal to r square sin square theta cos phi, this term, plus for this term, that is r cos theta cos phi. So r cos theta cos phi multiplied by, you leave this column and this row, so multiply cos theta into r sin theta cos phi. So r sin theta into cos phi into cos theta minus, if you multiply sin theta sin phi with 0, that will be equal to minus 0. Okay. Then for this term minus r sin theta sin phi, this term, you leave this row and this column and multiply sin theta sin phi with minus r sin theta. So minus r sin theta sin phi multiplied by minus r sin theta into sin theta. So minus r sin square theta. So here minus r sin square theta into sin phi minus cos theta into r cos theta sin phi. So minus r cos square theta sin phi. So if you solve this term will be equal to sin theta cos phi multiplied by r square sin square theta cos phi, that will be equal to r square sin square theta into sin theta sin q theta, then cos theta into cos theta cos square theta. Then the next term r cos theta cos phi multiplied by r sin theta cos phi cos theta, that will be equal to r square sin theta into cos phi. Here you have cos phi, so cos square phi, and cos theta into cos theta cos square theta. So r square sin theta cos square theta cos square phi. Then this, for this term, minus into minus, this will be plus r into r square, then sin theta into you have sin square theta, so sin q theta into sin phi, here sin phi, so sin square phi. Then next term, minus into minus plus r into r square, sin theta, here sin theta, then cos square theta, you have here cos square theta, then you have sin phi, so you have sin phi. So here you see r into r, that is equal to r square cos square theta, here cos square theta, then sin theta, this is here sin theta, then here sin phi multiplied by sin phi, this will be sin square phi, this will be sin square phi. Now you will solve it. If you will solve it, what you do here cos square phi, you write 1 minus sin square phi. Here also for cos square phi, you write 1 minus sin square phi. Then if you multiply, this will be r square sin q theta minus r square sin q theta sin square phi. So r square sin q theta sin square phi. Then r square sin theta cos square phi, if you multiply here, r square sin theta cos square theta minus, if you multiply this with this, then r square, here r square sin theta cos square theta sin square phi, r square sin theta cos square theta sin square phi. Then for this term, you see for this term, this will be r square sin square theta sin square sin q theta into sin square phi. So this term will be r square sin q theta sin square phi. The next term is r square sin theta cos square theta sin square phi, r square sin theta cos square theta sin square phi. So here r square sin q theta sin square phi, this will cancel. Also here sin square theta sin theta cos square theta cos square sin square phi will cancel here. R square sin theta cos square theta sin square phi, this will also cancel. Only you have two terms, r square sin q theta, another is r square sin theta cos square theta. So here if you take common r square sin theta, in the bracket you have if you take common r square sin theta, in the bracket you have sin square theta, and from here you have cos square theta, and sin square theta plus cos square theta is equal to 1. So the answer will be equal to sin square theta. So if you have given the coordinates, that is the Cartesian coordinate x, y, z, that is equal to r sin theta cos phi is equal to x, and y coordinate is r sin theta sin phi, and z coordinate is r cos theta, and you find out the Jacobian of the Cartesian coordinate, then the Jacobian of the in spherical polar coordinate, it will be r square sin theta.